Hello everyone, I'm 𝘎𝘰𝘯𝘊𝘵 and I'll be presenting a survey on recent advances in selective image encryption and its indispensability due to COVID-19. I am a final year student from SRMISC 𝘐𝘯𝘶𝘯𝘵, Chennai, and I'm the founder and team lead of Cognitive Applications Research Lab. So without further ado, let us try to talk about what our paper is going to study. We are all affected by COVID-19 right now, and we are in this paper going to first of all talk a little bit about what the impact of COVID-19 is on the use of multimedia, why it is being affected so much, and why selective image encryption is playing such a major role. Some of the primary effects of COVID-19 are we see that lockdowns have been imposed all over the country and internationally to varying degrees of strictness. This causes something called state boredom. Let me tell you what state boredom is. So in state boredom we consider both a neurological state of low arousal and also a subjective psychological state of being always dissatisfied or anxious, disinterested, frustrated, etc. This also leads to an increase in sedentary lifestyles and causes massive consumption of online information, usage of multimedia, maybe through social media, or even right now because of lockdown, since everything has moved online, be it from education to work. Hence, multimedia is being consumed at a huge rate. This causes massive stresses on the internet backbone, and we have already seen a lot of improvements in government policies and architectures. And besides that, we as researchers should be thinking of how we can develop better and more efficient algorithms which can encrypt these images in real time efficiently. So we'll talk a little bit about what is selective image encryption or SIE. For this, let us take an illustrative example. On the left, we have the Lena image, and in image encryption, if we are doing it in spatial domain, we usually have primarily two steps like confusion and diffusion. So we'll be dividing this image into blocks or some parts, and within each block or part, we'll be having some pixels. So we'll be shuffling all of them. The result of that you can see in the middle square here. Now, let us say that we have all of these values, and through a deterministic procedure, we'll be changing all of those values, and then we'll be getting the third square, or the final image, the final encrypted image. This shuffling and diffusion, the changing of the values is called diffusion, and the shuffling stage is called confusion. So this confusion and diffusion has to be done in such a way so that the image can be retrieved back from the decrypted image as well. So you saw one way we could do selective image encryption, but now let us talk about the various approaches with which you can do that. So one of them can be in spatial domain, one can be in frequency domain, and another can be in hybrid domain. Within spatial domain, we can have non-ROI based methods or ROI based methods. So what is ROI? ROI here talks about region of interest. In ROI based methods, we might manually select the regions of interest. For example, imagine we have a huge wall behind us, and I'm on Google Meet or some video conferencing tool, and we want to encrypt that image. So encrypting the entire white wall behind me is not very much required. So we can just select which parts of the image are important and we can do that. So one way could definitely be manually doing that, but that is definitely not efficient. So we can also have various automatic ROI based methods. It can be through edges, it can be through very simple small machine learning based models, etc. etc. Various methods have been proposed. With frequency domain, we can be encrypting some of the coefficients like AC coefficients, etc. And in hybrid domain, we could be combining some of the better aspects from both of these domains. We'll be talking a bit about these in the later part of the presentation. So what is the motivation for writing the survey paper? Primarily, it would serve as a guide for researchers working in the field of selective image encryption. We can also better understand the novel challenges brought onto this domain due to COVID-19. Finally, we can demonstrate some of our recent ongoing research, etc., and we can discuss our future avenues as well. So this survey satisfies all these goals. Now let's look at some of the prior approaches. So for example, G. Bhatnagar and Jonathan Wu's paper from 2012 that was of particular interest to us, and it presented a method of selective image encryption based on points of interest, or pixels of interest rather, and using singular value decomposition. In this method, the pixels were first scrambled and using the sawtooth based SFC, followed by a diffusion on the significant pixels using a secret key obtained by a nonlinear chaotic map and SVD. On the flip side, this might be a little slow, and determining POIs or pixels of interest might be inaccurate. In recent times, 𝘐𝘯𝘵𝘠𝘚𝑗𝑎𝑙 et al. They proposed a method of encrypting medical images using hyperchaos and DNA. They use Chen's hyperchaotic system and Taylor-Shirikoff map. And similarly, DNA and wavelet-based methods have also been proposed. This method was quite innovative, but it might appear to be a little slow, and also many DNA-based approaches have been cracked in the past. Murli et al.'s paper from 2017 used OPT and SFC for shuffling. It was fast and efficient. One of the particular pros of this paper which we found was that it proposed a technique called square wave SFC, which could fit images of any size as long as they are rectangular. It could fit images of any size, and it was very fast and efficient, as I already discussed. There were no cons of this paper as such. In 2019, Surrey et al. Proposed an interesting technique using TDES and LSB steganography. This technique was thrice as fast as 3DES. The second paper on my slide here, by Wen et al. In 2017, used saliency detection in compression domain. This thing was followed by encryption using parametric switching, chaotic system, and using DWT-CT. Here, DWT-CT stands for discrete wavelet transform, content transform. We won't go into how this works right now, but this is again a very interesting way to approach the problem. Tresser et al. In 2019 used selective encryption combining wavelet transforms and chaos and hyperchaos. So they used 2D DWT, Hennon's chaotic map, and 4D QI hyperchaos. Similarly, this paper is a very comprehensive paper which talks not only about the problems brought on by COVID-19, but how we can solve them using image encryption, why they are so important, and finally presents a very in-depth survey of the same topic. Previously, in 2015, Jawad et al. Had also discussed a survey of challenges in selective image encryption for color images based on three categories: ROI selection, encryption techniques, and key management, which was also very good, and I highly recommend you to read that paper as well. Comprehensive surveys based on image encryption in general have also been proposed in recent times. Without further ado, let's see some glimpses from our ongoing research. So when we're talking about selective image encryption, we are discussing we need these features to be there. It has to be selective, obviously, like it should not encrypt the entire image. It should find the important parts of the image and encrypt them more, or it should at least pay more attention to the important parts and very less attention to the unimportant parts. It should be secure. So when we say we should pay less attention to the unimportant parts, it should not be that the unimportant part was so badly encrypted that it was easily decrypted, and using that the rest of the image could also be decrypted. That should not be there. It should be lossless, like there should be no loss in quality of the image, which is of particular use when you are working with, say, medical images or military images, etc. And it should be very fast, as when we are working with so many different types of images based on so many possible deployment scenarios, speed is of great importance and concern. So one of the approaches which we are implementing right now, this is how it looks. So we here have a chest X-ray image, and it gets encrypted to the blockwise intermediate state, and then it moves to the final encrypted state. Similarly, here I have one of my photographs on Google Meet, and I took a screenshot of the screen of that size, and then I encrypted it, and you can see that the unimportant parts of the image, for example, where there is no writing, are pretty blank. There is nothing much there, but the important parts of the image, such as my face, have been encrypted quite well, and these have now finally been also encrypted and the entire values are changed, and you cannot actually identify from the final image which of the part or which of these blocks were important or unimportant. So great. This was amazing talking to all of you. I'd love to answer all your questions at the conference. I'm excited to see you there. Till then, thank you so much. Have a good day ahead.